Part 2 of 3.5, we're going to look at actually graphing the rational functions. Aren't you just so excited? Can't hardly stand it. And, you know, in the book, they say 7 steps. I do 6 steps. You know, I'm fine with you doing these steps since you're turning your work into me anyway. But, you know, as we go through, we're going to be looking at items that we calculated last time, and then how to actually draw the graph itself. So what I suggest doing is you can factor, if possible, numerator and denominator, and then if 0 is in the domain, find the y-intercept. Find the x-intercepts, vertical asymptotes, any holes, horizontal asymptote, and then the new stuff will be creating the table of values and sketching the graph. Okay, so let's look at a graph of 2x minus 1 over x minus 4. Okay, so first of all, nothing to factor, so we move on to the y-intercept because 0 is in the domain. Because my domain is x cannot be 4. So first I'm going to find my y-intercept. So r of 0 is 2 times 0 minus 1 over 0 minus 4, which is negative 1 over negative 4, which is 1/4. And I mean, I know it's going to be not a great point to plot, but you know, when I show you what I'm talking about, we're more determined positive, negative, above or below the horizontal asymptote, so it's okay. But that's one point. X-intercept. Now, by the process we learned last time, we multiply both sides by x minus 4 to eliminate my fraction. And I get 2x minus 1 is 0. 2x is 1. X is 1/2. So my x-intercept is 1/2 0. Vertical asymptote. Well, we kind of already found it when we found the domain. So x minus 4 is 0. X is 4. Horizontal asymptote. The degrees are the same. So I take the two terms with the highest degree, which in this case is 2x and x, form a fraction, cancel out my x's, and I get y is 2. So what I do, my process, is draw the asymptotes. It's always great to have a process to follow to organize things. So I'm going to draw my horizontal asymptote, my vertical asymptote at x is 4. Okay, maybe I should color code it. Let me see if I can find a red pen. Oh, there's a red pen. There we go. Okay. And then my horizontal at y is 2. And so what I've created here, I've created almost a new coordinate plane. 4 more sections. We've kind of shifted that original coordinate plane here. Okay. Now, my XY table what I usually do is I separate my 2/2 of my graphs with my vertical asymptote. So that's VA there. Sorry about that. At x is 4. Fill in your intercepts. So I've got 0, 1/4, 1/2, 0. Because I need points on either side of the vertical asymptote. So I've got points smaller, and I choose one that's bigger. What this tells me here, this 0, 1/4, and the 1/2, 0, both of these are below the horizontal asymptote. You know, you can look at 1/2, 0 here. And 0, 1/4 about here. And that just tells me that my graph is kind of confined in this quadrant, this new quadrant we've created in here. Okay, it's just a sketch, doesn't have to be perfect. But I need to know what's going on the other side of this vertical line, so I choose x is 5, substitute into the equation to find y. So r of 5, and again, all I care about is above or below horizontal asymptote. And so this is 10 minus 1, which is 9, over 1, which is 9. And so this is above the horizontal. So therefore, all of them are above the horizontal. So I just kind of sketch that in that quadrant. So then we can kind of see the symmetry, you know, is kind of what's considered about, you know, about the origin. That's it. Okay, so you know everything we found last time when we covered all these all go into the construction of the graph itself. The rest of it is just sketching these funky looking little curves here. Okay. So now let's do one that has 2 vertical asymptotes. Okay. So, you know, I'm going to factor this 3 over x minus 4, x plus 2. My domain, x cannot be 4, x cannot be negative 2. So therefore 0 is in the domain, so I can find my y-intercept. And you can certainly find your y-intercept before you factor it. It's probably easier. Okay. If I do 3 over 0 minus 4 times 0 plus 2 is 3 over negative 8, which is negative 3/8. Okay. So my y-intercept is 0, negative 3/8. X-intercept, you're not going to have any because there's no x's in the numerator. Okay, but if you don't believe me, I multiply both sides. It's a lot of work to prove me wrong. X minus 4, x plus 2, 0 times x minus 4, x plus 2. These all cancel. So I get 3 is equal to 0. False. So no x-intercepts. Vertical asymptotes. Well, we've got it factored. X minus 4 is 0, or x plus 2 is 0. So x is 4, or x is negative 2. Horizontal asymptote, degree 0. There's no x here, so degree is 0. So my this is the possibility too. Degree of your numerator is smaller than degree of denominator. So y is 0, which is the x-axis. So I'm going to draw my asymptotes. So x is -2. 1, 2, 3, 4. X is 4. And then we just kind of extend out here for the horizontal y is 0. So see, now we've created all kinds of quadrants here. So this is where it gets a little difficult, okay? Because in the middle, you know, this graph can do lots of things. It can be a parabola down. It can be a parabola up. It can be the S squiggly graph, the cube-looking graph. You know, this way, it could go the other way. So what we do here is, again, it's all about these vertical asymptotes. So for my table of values, I've got a vertical asymptote at -2, a horizontal, another vertical asymptote at 4. Okay. Now I fill in any points I've already found, so I do have 0, -3/8. Now what I'm going to do is I'm going to choose two x's that are immediately precede each vertical asymptote. So I'm going to put x is 3 and x is -1. That tells me, that'll tell me a lot. Okay. Then I'm going to pick an x smaller and then another x bigger, because I still need to know what's going on either side of the vertical asymptote. So I'm going, just for time purposes, okay, I'm going to fill in these numbers without showing you each one of them. So I just put each number back up here into the original equation, however you want to do it. Okay, there are probably going to be a lot of fractions, but again, I'm just looking at the relationship of the numbers, positive, negative, things like that. Okay, so if x is -3, that gives me 9 plus 6 is 15, minus 8 is 7. So this is 3/7, and again, it's above 0. Okay, so that's above the horizontal asymptote. When x is -1, sorry I crunched you in there. Let's see, that's +1 plus 2 is 3 minus 8, -5. So this is, oh boy, -3/5. That's kind of a pain, because it's going to be hard for many people to tell which one's bigger, which one's smaller. All right, that's okay though. You'll figure it out. When x is 3, 9 minus 6 is 3 minus 8 is -3/5 again. Okay. And then when x is 5, 25 minus 10 is 15, positive 3/7. Okay. So to graph this, all right, when I look at x is -1, I get -3/5, which is, you know, a little over half. X is 0, it's going to be a little smaller than that. But then again, when x is 3, I go -3/5 again. So therefore, I kind of know that this graph is going to be some sort of a U shape in here. Okay? Just because all the points tend to, you know, are smaller than 0. Now over here, -3 3/7, that's above the horizontal. So I sketch it above the horizontal. Over here, 5 3/7, above the horizontal. So it's all above the horizontal. So I really don't need to plot any points. It's just when you have two verticals, you kind of got to figure out the trend. as you get close to each one of these vertical lines. Okay. All right, that's probably as hard as it gets. Okay, those are difficult. The last example here is kind of an example with what we talked about earlier, were holes in the graph. Okay, so just for time purposes, my y-intercept, I've got 0, negative 1/3. My x-intercept, we're not going to do yet, because I'm going to factor this thing, and I'm going to show you what I mean when I talk about the holes. Okay, so when we factor, we can cancel these things out here. So therefore, I have a hole at x is negative 3. It's the opposite. Okay, so at x is negative 3, I've got this hole here. Now, I continue to work with what remains, the 1 over the x minus 3. So my vertical asymptote is x equals 3. So even though we started out with 2 factors down here, we ended up with only 1 vertical asymptote, but then we have a hole at the common factor we canceled out, because it's whatever gives us 0. So negative 3. So for my table, I need points on either side. Okay, well, I have one over here, 0, negative 1/3. Okay. And then I'm going to find another one there. Now, the horizontal asymptote, and I forgot I left that off, the degrees are different. Numerator smaller than denominator, so it's just the x-axis here. And then when x is 4, I get y is 1. Put it back up here into this equation here. X is 4, 1 over 1 is 1. So at 0, negative 1/3, I know it kind of goes right down through here, but right here is where our hole is. So it kind of comes up to here, then it continues on around it. There's no point we're plotting there. And then the other one, 4, 1, is above the horizontal asymptote, so I sketch it there. So really the only difference when you have a hole is you just don't draw the other vertical asymptote, and instead of drawing a continuous line, you kind of break it up into 2 parts, one on either side of the hole there. Okay, so that's the graphs. We will again work more of these and do more practice when we meet.